All right, number one, classify each polynomial according to its degree and type. So remember, if it's a monomial, that means it's going to have one term. Remember, a term is separated by a positive or a negative sign. So a binomial will have two terms, and a trinomial will have three terms. Remember, if it's to a degree of 1, we're going to have, say, like x, since we're using x's there, and it would be to the first power, but remember, we never show first power. And remember, it can have a number in front of it, so we should be able to see that one pretty easily. And then degree of 2 and a degree of 3. That means that the largest x will have an x cubed term in it. Remember, it does not always have to be right in front. That's the way they would like you to write it, but it doesn't always have to be that way. So let's look at our first one here. Do you see one that looks like a degree of 1? Remember, it doesn't have to have one, and it's a monomial, which means it's one term. There's no plus or minus. And you should say, yeah, I'm going to drag that 3x over here. Okay. A binomial, again, would have one plus or minus and an x to the first term. You should say, oh, I see 2x plus 5. And then the last one, there isn't one. So since this is drag and drop here, I am sure you would leave this one blank. All right, so now same thing, a monomial with the degree of 2. You should see that as negative 4x squared. With the binomial, so two terms with an x squared, you should see it's 3x squared minus 8. And then one that has three terms with a squared. Remember, I told you it doesn't have to be in front, but if you notice that one right there, it has a squared term to it. So our answer would be, because you would drag and drop, negative 2x plus 5x squared plus 1. And then finally with the degree of 3, you'll see that 6x cubed. You would see negative 9 plus 3x cubed. See, even with binomials, it doesn't have to be in front. And then the last one there would be, let's see, 3x squared plus 4x minus 10x cubed. Okay, the second one here, what you're going to do, ladies and gentlemen, is again, you're just going to have to, I believe you're going to have to move these up and down. Once you figure out which one they are, they're going to go in order from least to greatest. So the smallest or highest negative number, if you want to think of it that way, think about it as on a number line, and then to the highest number. So on any of these, it's just going to be basically a plug and chug. So you're going to say negative 2. Remember, you're going to plug in negative 1, and we're going to cube that, plus 8 times negative 1 squared minus 5 times negative 1 minus 6. Now you should just be able to plug it into your calculator exactly like it shows right there. All right, and if you do that, for the first one, you'll get a 9. For the second one, and again, I would plug them in just to make sure I'm not lying to you, you'll get negative 6. You'll get negative 5. On this one here, you'll get a 0. And on this one here, you'll get negative 3. All right, so they want us to go in order from least to greatest. So negative 6 will be our least. Then we would have negative 5. Then we would have negative 3. Then we would have 0. So basically that one you don't have to move. But this one here you would move all the way down to the bottom. Okay, let's see. Number 3, excuse me. Number 3, it says describe the end behavior of the graph of f of x is equal to 3x cubed minus 10x to the fifth minus x squared plus 14. On this one right here, remember, we talked about it was in the very first section. So we knew if it's a highest degree is there, right? So that would make it an even function. If it was an odd number, it would be an odd function. But with an even function, remember, they're both going to go up or they're both going to go down, all right? What'll tell you if they're both going to go up or they're both going to go down is that number right there, and it's positive. So since that's positive, that tells us that they're both going to go up. All right. So if that's the case, again, I can just draw you a quick little thing here. So here's my x, here's my y. And remember, I said there, it's going to have something here. So that one's going to go up and that one's going to go up. Okay. And something else is going to happen in between there. Remember, I kind of did something like this. Okay. So remember, I told you I don't like the way the book does this, but if we look at it, as x approaches negative infinity, so this is our x-axis, as it is approaching negative infinity, what is our f of x going? Well, our f of x is going all the way up, so it would be positive infinity there. And the same thing here, as x approaches positive infinity, f of x is also approaching positive infinity. So it'll go there. Your book just likes to say it backwards. All right, let's see. Find the sum. And write your answer in standard form. Remember, standard form means from highest exponent to lowest exponent. So again, if there isn't one in one of them, you just have to say it's like a 0 there. So if we look, we have a 4x squared cubed there and a 4x cubed there. So 4x cubed plus 2x cubed is 6x cubed. There's no x squared term in this one. There is one there. So it's going to be minus x squared. There's a positive 2x here. There's no x in the other one. So we'll say plus 2x. And then we have 6 plus 2. So that would be plus 8. All right, excuse me, find the difference. So remember, if we find the difference, if we have something outside the parentheses, that means I'm going to multiply it all the way through. So we're going to have a plus here, but then we're going to have a negative 3x squared. We're going to have a negative 4x, and then a negative times a negative is a positive, so we'll have plus 5. So again, just like we did on the other one, on number 4, negative 2x plus a negative 3x, negative 2x squared plus a negative 3x squared, that will give us negative 5x squared. There's no x term in the first one, so it's going to be a minus 4x, but we have now 3 plus 5, which will be 8. Okay. On number 6, it says identify each product. So on this one here, you could FOIL, or you could remember the pattern. So if you remember the pattern, remember I'm going to take the first term and I'm going to square it. I'm going to take both of them and multiply them together. So x times 2y is 2xy, and then I'm going to multiply 2 to that. So 2 times 2 is 4, so we'll have 4xy, and then I'm going to take and square the last term. Remember, I square the number also, all right? I square the number also. So that will be 2 squared, which is 4, and then I'll have y times y, which is y squared. Okay. So on the same thing here, The only thing they're trying to do on the second one to throw you off is I'm going to say y squared, but again, this one looks just kind of like the same one there, except now it's 2 times 2 is 4 times x times y. And when we put it in standard form, remember, alphabetical order. So you would see that's why you have 4xy down there as a choice. And then again, 2 times 2 is 4, x times x is x squared. Okay. Number 7, identify each expression that is equivalent to 5x plus 4y and 5x minus 4y. So remember on this one here, ladies and gentlemen, it is a difference of squares. So or difference of 2 squares. Let's make it even more to you. So remember, what we're saying is it's going to be a difference. So we know we're going to have a minus there. And remember, I can take the first term and I'm going to square it. And then I'm going to take the last term and I'm going to square it. All right, so you should see one that looks like that, and you do. That would be this one right here. And now remember, when I have this, I can also say 5 times 5 is 25. X times x is x squared. Minus 4 times 4 is 16. Y times y is y squared. So you should have clicked on both of those. Okay. And I did show you both of them in my notes. So that's why I think it's a pretty valid question. Now, which of the following is equal to 16x squared minus 144? So this is, again, just the same idea backwards. All right, so in this one here, if you think about it, what times what gives you 16? That would be 4. And then I'd have 4x squared. And then, remember, I told you you should memorize up to 14 squared, which is 14 times 14. 12 times 12 is 144, so you'll have this. All right. So this looks like the 5x squared minus 4y squared up above. And so then we can write it as a difference of squares. So we're going to write 4x plus 12, 4x minus 12. Okay, so that would be that one right there. And another thing you could do if you're not sure, ladies and gentlemen, is you could actually FOIL all of those and multiply them if you want, or you can remember the simple way. Okay, it's up to you. Same thing with number 9. On number 9 here, we have a pattern. You could also use Pascal's triangle, but I said to use Pascal's triangle for number 10, but you could still do it on this one here, or you could remember the pattern. So remember, on the sum of cubes, in the book, I told you it was a plus b cubed is equal to a cubed plus 3a squared b plus 3ab squared plus b cubed. So in this case here, again, this is our A. Our A is 3b in this case, and our B, and when I'm following the pattern in this one, is 4. So again, if I'm going to follow this pattern, I'm going to write 3b cubed plus 3 times 3b squared times 4 plus 3 times 3b times 4 squared plus 4 cubed. All right, so let's see if I can remember what this is going to be because I didn't write it all the way down. So 3 times 3 times 3 is 27. So I'll have 27 b cubed plus, let's see, 3 times 3 is 9 times 3 is 27. 27 times 4, that'll be 8, carry the 2. My thing is right, I'll have 108 b squared plus I'll have 3 times 3 is 9 times 4 times 4 is 16, so 16 times 9, that'll be 4, carry the 5. I should have 144. B, and then I know 4 times 4 times 4 is 64. Not too bad for not having written it all the way down, I think. Okay. So now, again, I told you could have used a Pascal's triangle, but I think it's always easier to remember the other ones. Start using Pascal's triangle from the 4th power on. But remember, on that right there, I kind of showed you this little pyramid. So we have 1, here's 1 and 1. And then again, I'm kind of adding the middle ones. And then I'll have 1, I'll have 3, I'll have 3, and I'll have 1, which is kind of, if you look at the pattern above, that's what I ended up having. So on this one here, I'll have 1, I'll have 4, I'll have 4, I'll have 6 there, I'll have 4 there, and I'll have the 1 there. So this is your 4th row. So that's the one we're going to use. All right, so now remember, what I kind of told you to do is I told you to take and put the 1, 4, 6, 4, 1. And then I told you to take your A, which in this case is 4, and you're going to take that and you're going to start decreasing it. And then you're going to take your 3y and it starts at 0. So now I'll have 4 cubed here. And I'll have 3y to the 1st power. Here I'll have 6 times 4 squared. Notice how the 4's are going down and the 3y's are going up. And then I'll have plus 4 times 4. I didn't give myself enough room there. That would be 4, and then here I'll take my 3y and it's increasing, so that'll be cubed. And then I'll have 1, and I'll have 4 raised to the 0 power, and then my 3y will be to the 4th power. Okay, now remember on this here, we know that anything raised to the 0 power is 1. So we know anything raised to the 0 power is 1. So then the rest of it is just plugging it in. So 4 to the 4th, that will equal 256. And then I have 4 to the 4th, which again I just told you was 256, and I'll take that times 3. That'll give me 768. And it looks like we have y to the 1st power. On this one here, I have 6 times 4 squared, 6 times 16 times 9, which will give me 864. And that'll give me y squared. Plus 3 times 3 times 3 plus 4 times 4, which is 16, which will give us 144. and that will be y cubed. And 3 times 3 is 9 times 3 times 3 is 9, so 3 to the 4th is 81. And that will be y to the 4th power. And that is what you will put in for your answer. Okay? On number 11, this is probably going to be one of the hardest problems for most of you. All right? So if we look at this one here, it says divide x to the 4th plus 2x squared minus x plus 1 by x squared plus x plus 1. So luckily I have a little room here. So remember, if I look at the exponents, if one is missing, I have to put a 0 there. So if we look at that one right there, I have x to the 4th. I don't have an x cubed, so I'm going to have to put plus 0x cubed. Then I have plus 2x squared. And then I have, minus x plus 1. Remember, that is being divided by x squared plus x plus 1. So, as I've said before, ladies and gentlemen, look at that term there, okay? And look at that term there. This one is to the 4th. So x times what? X squared times what gives you x to the 4th? All right? So think of it that way. And then my suggestion is always to put it where that one is. Then that kind of tells you where to stop. So I know that x squared times x squared will give me x to the 4th. So I'm going to put an x squared right there. Okay? So now I'm just going to multiply each term. So x squared times x squared is x to the 4th. X squared times x is x cubed. X squared times 1 is equal to x squared, and that one is positive. Remember, when I'm doing long division, just like we did with numbers, I've said that before, I am subtracting them because that makes them go away. So x to the 4th minus x to the 4th goes away. I get 0x cubed minus x cubed because of minus. So that'll be negative x cubed. And then I have 2x squared minus x squared. Well, that will give me a plus x squared. And then remember, I bring down the next one. So minus x. All right. So again, I'm going to look at this again. So x squared times what gives me x cubed? And hopefully you can see, since I do have it right here, I'm going to put a x there. All right, so that kind of tells me I'm going to have one more thing after this. So again, I'm going to take x times x squared, which will give me x cubed. I'm going to take x times x, which will give me x squared. Yep. And then I'm going to take, let's see. Oh, okay. I'm sorry, and I'm not going to refix this, but I'm going to fix it here, but I'm not going to start all over again when I only have 3 other problems left. I have a negative there, right? Since I have the negative there, that one here, this should be negative. See, I was doing it and I noticed something was wrong. So if that's the case, then remember that means I'm going to have a negative x cubed here. and then I'm going to have a negative x squared there, and then I'm going to have negative x times 1, which is negative x. And again, I'm going to be subtracting all of that again, all right? So think about it. I have a negative x squared minus a negative, which is positive. Those are going to go away, all right? So then I have x squared minus a negative, so I'll have 2x squared here, okay? I have negative x minus a negative, or positive, so I have negative x plus x, so that will give me, again, let's just go ahead and put a plus a 0x there, and then I will have to bring down the 1. So this will be plus 1. Okay, so now I'm going to do the same thing one more time. X squared times what gives us 2x squared? And you would tell me it would be plus 2x. All right, and when I do that, I'll get 2x squared here. I will get, let's see, 2x times x, which will be, not 2x there, darn it, that's 2, not the x. So 2 times x squared gives me 2x squared. 2 times x gives me 2x. 2 times 1 gives me plus 2. And again, I'm going to be subtracting those. And that's plus 2x. So when I do that, those are going to go away. Then I'll get 2x there. And 1 minus 2 is negative 1. And that's a minus there. So remember, this part right here has to go over our divisor, which was this right here. So our answer is going to be x squared minus x plus 2 plus, and I would write it this way just because I think that's what they're going to want you to do. So, because you're just going to do plus, and then you'll have the 2x minus 1 over x squared plus x plus 1. All right. So if you write it that way, I know some of you would say, can I factor out that negative and put it there? But I'm pretty sure that they'll want it left like it is. So just go ahead and leave it like that. All right. So almost done here. So the area A in square feet of the rectangular shed is given by 6x cubed plus 7x squared plus 11x plus 21. Use polynomial long division to find an expression for the length in feet of the shed. So what they want us to do is we need to find this. So we're going to take our 6x cubed plus 7x squared plus 11x plus 21, and we're going to divide that by 2x plus 3. And we're going to do the same thing as we just did with the other one. So 2x times what gives you 6x cubed? And you would tell me why that would be 3 times 2 is 6, and then you'll tell me x squared. So that's why I put it over the x squared term. So again, I work that out, I'll get 6x cubed here, and I will get plus 9x squared here. Again, when I subtract them, those are going to go away, and then I'll have 7x squared minus 9x squared, which will give me minus 2x squared, and then I'll bring down the 11x. When I get the 11x, I'll do the same thing. 2x times what gives me negative 2x squared, and you would tell me negative x. And again, negative x times 2x is negative 2x squared. Negative x times 3 is negative 3x. And again, I'm subtracting those. So negative 2x minus negative, but it's positive, those are going to go away. 11x minus a negative, or 11x plus 3x will give me 14x here. And then again, I'm going to bring down the 21. So plus 21. And since they're telling us on this one here, it should make sense that I should not have a remainder, because it just wouldn't make sense on this kind of problem when I'm trying to make a rectangular shed to have a remainder. So again, if I do that there, did I write that down right? Is it plus 21? Yep. All right, so again, I'm going to do the same thing here. I want to get rid of that. So let's see, 2x times what gives us 14x, and you would tell me that would be plus 7. So 2 times that, 7 times 2x is 14x. 7 times 3 is 21. And again, I'm subtracting them. Those go away, those go away. That's my 0. So my answer then, again, since there's no remainder, it's just what's on top, it'll be 3x squared minus x plus 7. I really had a hard time finding a synthetic division problem that I liked, ladies and gentlemen. So I did find this one. Use f of x is equal to negative 4x cubed plus 3x squared minus 17. Remember, we're going to have a lot more of these when we factor out other stuff. So I'm not really that concerned, because you will see that I will be doing this. So what we have to remember is that f of 2, negative 2, that will be our remainder. So now, remember on that here, so when it was this way here, remember I told you when it says x equals, we're just going to go ahead and make our negative 2 be the one on the outside. Then we are going to take our numbers. And remember, if one is missing, you have to put a 0 there. We're just taking the coefficients. So I'll have negative 4, I'll have 3. There isn't an x term, so I have to put a 0 there. And then I'm going to put a negative 17. And remember, my suggestion to you was to put a little bar in between the last two numbers, because then that will tell you that's our remainder. All right. So remember, I take the first one and I bring it down, and then I just start multiplying. So negative 2 times negative 4 is positive 8. Remember, I now add, not like with long division. I add, so 3 plus 8 is 11. Negative 2 times 11 is negative 22. 0 plus negative 22 is negative 22. And then I have negative 2 times negative 22. That will give me a positive 44. And 17 minus negative 17, plus 44 will give me a plus 27. So that's my answer right there. F of negative 2 is equal to plus 27. Now remember, the remainder theorem, and if you go this way, I'm not going to know, am I? Because it doesn't ask to show your work. But remember, you could just plug in negative 2, kind of like we did up at the top on the second problem, and we can just find out that it would be 27 that way too. All right, 2 more here. I made it a 15 problem test, so hopefully that'll help you factor completely. So on this one right here, again, you have to look and see what you think is in common in both of them. All right. So when I factor it completely, I should have a negative 4y here, and so is 108 divisible by 4? And hopefully you'll say yes, because then I can factor out the negative 4y. And then what I'll have left is negative 4y. I'll have 1, and then I'll plus 27, and then we have y cubed. Okay? So, and if you want to check, you can always take negative 4 times 1. That does give me negative 4y. So think of it that way. Now look at this one here, all right? And this here is a sum of cubes. And remember, we had a special pattern for that, because remember, I can write 27 as 3 cubed, and I can write y as y cubed. And 1 is, of course, I can always cube in 1, because 1 cubed is just 1. All right? So if you think about it that way, then I can go ahead and use the pattern that's in your book and in your notes. So kind of look at it, ladies and gentlemen. But I'll take the 1 plus 3y. So that goes there. And then I'll take the 1, and then I'm going to subtract, and I'm going to take just the first term and the last term. So 1 times 3y, and it's just going to be 3y there. And then I'm going to square the last term. So 3 squared is 9, y squared is y squared. And that is as far as I can go on that one. That is factored completely. You'll have them very similar. And then the last one, remember on this one here, it was a special form. There's 4 terms. So when there are 4 terms, I told you to group them. So when you group them, you're going to take this one and this one together and think, what can you factor out there? So I see 12 is 4 times 3, and 8 is 4 times 2. So it looks like I can take out a 4, and let's see, can I take out a y squared? Yep. Okay, because again, I had a y squared here, and a y cubed there. So the lower power I could actually take out of both of them. All right. So now, what do I have left there? I have 3y right? And I have plus 2. Okay, so now remember, what I need to see now is on this one here, I need to have the same thing. So I need a 3y plus 2 here. And how can I get that? Well, can I factor out a negative 1? Okay, so on these two here, I factored out a negative 1 because I needed 3y plus 2. Okay, so now remember, I can now rewrite this as 4y squared minus 1, and then I have 3y plus 2. But now hopefully, ladies and gentlemen, and I'm sure some of you thought about this, but again, don't I have a difference of squares here? Or 2 squares? Again, hopefully you'll see it. Hopefully you can say, yeah, because this is 2y squared. And again, 1's one of the easiest ones because I can always square it, I can cube it, I can do anything to it. All right, so I do have a difference of squares there. So remember, it's going to be 2y plus 1, 2y minus 1. So now to factor it completely, I'm going to write is equal to 2y plus 1, 2y minus 1 times 3y plus 2. And that is my answer that I will put there. All right. I'm pretty sure it doesn't matter which order it goes in. Of course, I always look at your answers to make sure. Okay, so good luck. Hope you like this, um, and I hope you do well on the test. Remember what my suggestion was. Okay.